We're going to determine whether a function is continuous by looking at some graphs. The first graph we have is just some little squiggly line on a graph, and we're going to look at limits. So we're going to say is, I'm going to get that up a little. We notice that the limit as x approaches c from the left, that means this portion here, equals, and I'm going to say of f of x. So these graphs are called f of x. Equals the limit of, as x approaches c from the right, because you come down here and it goes to c, of f of x. So that means the limit as x approaches c in general of f of x exists. And the limit is as x approaches c of f of x equals f of c. So it's this point right here. This is f of c. So if this was 3, it'd be f of 3. All right, on this one, we have a hole here and a point. It's a piecewise function. And what we're going to say is, I'm going to move this up a little again. We have, we're going to check the left side. The limit as x approaches c from the left. This is this portion. If f of x does equal the limit as x approaches c from the right of f of x. So when I come from to the right, so basically you're going from x, you're going to the right. This is going to the right. This is coming from the left. And they all approach c. So the limit does exist. Because they're the same. It's this right here. This is going to be your f of c. Exists. However, the limit as x approaches c of f of x does not equal f of c. So the limit exists, but it can't equal it because there's a hole there. And this little part here makes no difference. Okay, the next graph we have is, if you notice this, there's a bit of a jump. So when you travel along here, you go here, and then you have to pick your pin up and jump to go to here. You have to pick your pin up and jump to go to that. So what we're going to say is the limit as x approaches c of f of x does not equal, this is from the left, the limit as x approaches c from the right of f of x. These are two different values here. Therefore, the limit as x approaches c of f of x does not exist. And I'm just going to write does not exist like that. All right? And we could also say that f of c is not defined. Okay? Now, this one, we have the limit as x approaches c from the left of f of x does equal the limit as x approaches c from the right. So it still comes to this c here. All right? It's this point right here. Therefore, the limit does exist. However, f of c is not defined. There's a hole. So a lot of vocab here. We have two more of these. This one's like the previous one we did. So what do you think? Does the limit exist? The limit as x approaches c from the left goes up to here. And that does not equal the limit as x approaches c from the right, which would be this. Therefore, the limit as x approaches c of f of x, this is f of x again, y and x does not exist. Okay? And f of c is not defined. There's a hole. It's not defined. All right? And what do you think about this one? Yes, you're right. The limit as x approaches c from the left does not equal the limit as x approaches c. So this is from the left, this is from the right of f of x. Therefore, the limit of as x approaches c in general does not exist. But f of c is defined. All right. Now, the next the next graph I have is this. So this is the graph of f. I'm just going to call it, whoops, sorry. This is the graph of f. And we're going to ask some basic questions about this. And I'm going to keep flipping back and forth on the graph. I'm going to try to go fast. So if you need to pause, you can pause. The first thing I want to do is find the domain. And the domain, we're starting at -8 and going to 6, although we have some holes here and some asymptotes. So the domain, basically, I'm going to write it here, is we're starting at, let's see, -8, and then it goes to 6 without equaling it. So that's an open interval. This is closed interval. Or, then that means we're jumping. We're going to -6, 4, open interval. It can't equal -6 and 4. Or, and then we're going to go to 4, and then it can equal 6. So if you want to go back and look at that, write this down and go back and look at the graph. Do you see where it jumps? It can get close to 6 here, then it starts back at 6 and it can equal 4 and so forth. So you might want to look at that on the domain. The range is a little different. The range, we're going to start from -infinity because we're starting down here and it goes all the way up in here. So the range is a little easier. That's just going to be -infinity to infinity. The x-intercepts are where it crosses here. So it crosses at 1, 2, 3, 4 places. So I'm going to write the x-intercepts, and they're going to be, why do I have 3 places? So x-intercept is when y is 0. So we have -8, 0. We have -5, 0. And we have -3, 0. I thought we counted 4. Oh, this one doesn't count because it's open. All right. Now, the y-intercepts is when y is 0. So let's go back. And it looks like we just have 1. So that's 0, 3. And now you should know how to do function notation. We're going to look at f of -8, -4, 2, and 6. So f of -8 is at 0. So that's that point. So f of -8 equals 0. F of -4 goes to 2. It's right in there. F of 2, let's see, goes to 3. I'm going to put 3 here. And f of 6, whoops, sorry, f of 6 goes to 2. So f of 6 goes to 2. So that's just basic stuff. You should have learned in pre-cal. Now let's do the limits. We want to take the limit as x approaches 6 from the left of f of x. So when we look at that, and I'm going to keep going back, so as x approaches 6, negative 6 from the left, so we're going from here, from the left, we're going up here, so from here, and that goes to infinity, because there's an asymptote there. So as x approaches, it's just supposed to be negative 6. From the negative equals infinity. And as it approaches positive, it goes to negative infinity. Because it's going down. Alright. The next one is the limit as x approaches negative 4 from the left. So when you look at negative 4 from the left, it's going up to 2. Alright? So the limit goes to 2. And then from the right on 4, it goes to negative 2. You want to look at that. So from the right, it goes to negative 2. Next one is the limit as x approaches negative 4 of f of x, does it exist? And it does exist because as the limit approaches x from negative 4 from the right, from the left, and from as it approaches negative 4 from the right, that equals 0. And since they're both the same, you're going to say yes. Okay, now we're going to say, is f continuous at negative 6? Since f of negative 6 doesn't exist, then we're going to say that the limit as x approaches negative 6 of f of x does not exist. Okay, is f continuous at 0? It is, because the limit as x approaches 0 from the left equals the limit as x approaches 0 from the right. And that limit equals 3. So the limit does exist, and the limit is 3. Okay? F of 4 does not exist. So there's no limit. So f is not continuous. There, since it's going to be a jump. So let's look at that again. We're going to go to 4. Do you see the hole there? So it's not continuous, because when you're taking your pen and drawing here, you have to jump. Alright? And f of negative 6 doesn't exist because there's an asymptote here. So you might want to copy the graph down before you do this, because this is kind of hard going back and forth. Alright, so we're going to look at f as f approaches negative 2, or 2 from the left. So we look at f as x approaches 2 from the left is 1. So this would be f of x equals 1 as the limit x approaches 2 from the left. When we approach from the right, f of x equals -4. Since these two numbers aren't the same, the limit as x approaches 2 in general of f of x does not exist. Okay? Now, the limit f is not continuous at 2 because f of x, the limit, the same reason here, basically. It doesn't exist because the limit as x approaches 2, f of x does not equal the limit. Why do I want to keep writing that? X approaches 2 from the positive side of f of x. So, no. The question is that, and you say no, because it doesn't equal. So let's go look at 2. Keep going back. All right. When you approach 2 from the left, we get this number. When you approach 2 from the right, here, so this is your 2, that's your C in this case, equals -4. So you get 1, -4. They don't exist. All right. And let's see if f is continuous at 5. So let's go back. This is the last one. So here's 5. And we're going to ask is f is continuous at 5. So at 5, we're right here. And that's at 1 here. So since approaching here to 5 equals 1 and approaching from above equals 1, that's continuous there because I don't have to raise my pen to get there. So we're going to say yes, and because f of 5 equals the limit as x approaches 5 from the left of f of x, which equals the limit as x approaches 5 from the right of f of x. And the limit of both of those as x approaches 5 in general equals 1. And this all equals 1. Okay, the next video I'm going to do is piecewise functions, and I think we can get a better idea of continuous functions and limits, and do the limits exist.